All right, everyone, welcome back to stage one, right? We got a great talk up for you, and actually, we recorded this one as well. I think these are the only two, I believe, that will be recorded. Mohammed Shine, um, he actually apologizes. He got married the other day, and you know, stuff happens. So unfortunately, he wasn't able to make it. He was able to at least send us a video about about his experience with hacking APIs. So just quickly to Mohammed, actually he's an avid photographist, motorcyclist, loves doing security things as well. He's also supporting ASRG in Kerala. He works for AppSec, I believe, and this is some of his research that he found this year. So we're really happy to have Mohammed Shine with us today, and please enjoy the talk. Any questions, I'll try and answer at the end, but I don't think he's going to be able to answer any questions today. All right. Thanks, guys. Have fun.
Welcome to the session. Hope you're all doing well. Today, I'll be talking about a vulnerability that was found by me recently. And thank you, ASRG and the Secure Streets team for organizing this event. I would also like to thank them for inviting me to present my paper. So, my title is Hacking a Connected Car via APIs. So, this was recent finding in a connected car, and which allowed me to completely take over the car through its vulnerable APIs. So let's into the session, and yeah, let me introduce myself. My name is Mohammed Shine. I am a security engineer, mostly working in the mobile application and the web application side, and I'm from India, and I'm also an occasional bug bounty hunter. I've been listed in the Hall of Fames of Apple, Google, T-Mobile, etc. I also lead the Kerala chapter of ASRG. I also volunteer at the Defcon Trivandrum chapter. And apart from my cybersecurity experience, I am also an adventure motorcyclist and an automotive photographer. You could check my Instagram profile, which is mentioned here. Could visit my profile to see my automotive photography and the videos. Uh, yeah. So yeah, thanks for joining my session. Like, let's move to the session. Okay, mobile applications in the IoT device and the IoT device integration. So, like previously, we could see that the home automation was one of our major advancement, and before we use manual switches to switch on our lights, and now we could use our mobile or smartphones to control our room lights, TVs, everything that is everything in the home. So that's how far we came. And the retail experience, the retail stores like Amazon Go is an example where mobile applications play a major role there. So IoT wearables, and I own a smartwatch, and I can't even change the time from my watch. I need to use the mobile application of this watch to change the time. So that's how what mobile application and IoT devices are connected each other. So these advancements has what changed the automotive industry as well. So previously we could use previously the traditional cars were like they were just mechanical devices, but now a car is something, it's like a computer, an Excite computer on four wheels. So what are the advantages of using mobile application in cars? So you could use instead of key fob. First thing is that you don't want to carry your key everywhere. You could use your mobile or the smartphone to start or open the doors. So then comes the RSA features like roadside assistance. Whenever you are stuck in somewhere in a lone place, you could use the mobile application to call or the to notify the service assistance, and it's easy to use. if you know how to use a mobile phone or a mobile device, obviously you could use the mobile app as well, and track your car. You could use the navigation systems and the track your how find my stolen car features, etc., to find your car. So that's how that is the relationship between a mobile app and car. So but like I'm from India and we don't have much advancement here, but most of the countries are adapting to mobile applications recently for automotive industry. And yeah, then there comes connected car. A connected car is one that has its own connection to the internet, usually via wireless local area network. I copy pasted this from Wikipedia, so you don't want to what read this. A connected car is something. Connected car is a car that is connected to the internet, and that makes it an IoT or an internet connected device. So that's a connected car. So then, when we speak about connected car, TCU or the Telematics Control Unit is one of the major thing that should be what considered. So before that, TCU is Telematics Control Unit in my session, and please don't mistake it with the transmission control unit or the gearbox systems. So that's entirely different. But in this session, the TCU will be I'll be mentioning TCU as Telematics Control Unit. So the Telematics Control Unit is the embedded onboard system that controls wireless tracking, diagnostics, and communication to and from the vehicle. Yeah. So telematics control is a hardware that is placed in the car, and that is used to connect to other vehicles or the other infrastructures. And there are many things that can be like the modern cars have different communication systems like or the communication technologies like V2X, V2I, or V2V. V2X is vehicle to everything, and V2I is vehicle to infrastructure. For example, consider there's a smart traffic system and you have a smart car, and V2I enables you to connect your car to the traffic system and notify you about the traffic status. And V2V is like two cars can be connected to each other and they can transfer the data. So TCU has the following components: a satellite navigation system or the GNSS unit. It also has a microcontroller, and it has a mobile networking unit, an external unit for cellular communication like Wi-Fi, GSM, etc. And 5G. Like modern cars use 5G and Wi-Fi mostly. So then comes a unit that processes the electric signals. Yeah, obviously there should be something to connect to the car, right? So car itself has an internal network, and that needs to be connected to the TCU as well. So then comes the storage unit. It also is a small storage unit for storing and storing the data. And it also has a battery module. So by this, you could understand that it or the TCU acts as a separate device, and it will be working 24/7, mostly in 24/7 in most of the cars. So also, I would like to recommend if you are new into the automotive security testing, TCU will be a good place to start start your research or testing. So I started with the CAN bus attacks and the key fob attacks, but in India we don't have much support for automotive testing. There are restrictions from the customs, so we can't buy the hardwares that can be used to test the cars or the components of a car. So TCU is entirely different. It has its own protocols, and most of the protocols are common. So you could attack, or you could check the vulnerabilities that can be affected in those protocols. So it's just a recommendation from my side. If you're if you're starting in the automotive security industry, like testing side, you could check TCU as well. It's a wonderful place to start. And for the research, I used Honda City 5th Gen. And the reason is so simple because in India, we don't have much advancement in the connected cars. This is the first connected car in India, and it was launched in 2020. I'm sure that most of the countries have connected cars from 2015 itself. So this was the only car that was accessible by me to test. And there's an interesting story that how I came up, like how I came to this car. I'll be explaining in the later slides. And attack surface. So now, like we talked about why mobile applications and how, like, what are TCUs and what are the car communication stuff. But like everything, for like as a pen tester or a security analyst, mostly who like I work in the application security side, we have an attack surface. And for example, the login page and registration page are some of the critical places where we check for vulnerabilities. So like that, in car, we can break down the attack surface like this. So the Wi-Fi or the networking side, then the OBD. OBD is onboard diagnostic port, and you could use, you could use this OBD to get access to the network and the internal network of the car, etc. Then you could also use software updates. There were vulnerabilities in software updates. For example, some cars use manual updates than the OTA updates, so over the air updates. So you could use your USB to update, download the software and just plug in to update your car. But you could use malicious codes inside the updates, and you could test for vulnerabilities or attack the car. Yeah, that totally depends on your side. If you are a black hat, you'll be exploiting it. If you're a white hat, you'll be notifying the vendor. So that totally depends upon you. So these are the places where we could check for vulnerabilities. So my area of interest is mostly on the mobile application side and the infotainment system, also the key fobs. So for this research, I selected the mobile application side, the Android and iOS. Okay, now this is a story that that made me to test the Honda City car. So this article came came to my notification or something like that. I used to read articles about car hacking, and one day this article came in front of my eyes, and I after reading, I was very much what interested about learning about the telematics control unit. So the article was about a researcher. His name is Jos Carlos Note, and he was able to hack trucks. Internet connected trucks can be tracked and hacked, researcher finds. That was the title. And the thing he did was the telematics control unit uses a not vulnerable, less secure protocol like Telnet to interact with the truck. So the TGU was vulnerable, and he could take over the TGU and the truck. So I was like, "Whoa, this is nice." So I replicated the same attack. So before that, what is it, like I have mentioned about telematics control unit, but telematics gateway units are different. Telematics gateway unit has a high performing application processor hardware platform at its core. It offers various advantages when compared to a TCU. This includes higher data throughput and capacity to store offline data for a longer time. So this is what a TGU is. TGU is advanced or a higher version of a telematics control unit that can process more data than a TCU. Okay, so I replicated the same attack. I read the article and I understood that he used Shodan, the search engine for IoT devices, and to enumerate the devices. The vulnerable TGU was the C4 Max TGU, and I searched it in the Shodan, and I was amazed. Actually, there were 228 results found, and I was able to get access to a TGU. You could see the screenshot here. This the whole research what belongs to Joe's, and I was just what copy pasting his same methodology. And I was what very much interested about learning about the telematics control unit and the gateway unit. So my Google search was fully loaded with TCU and connected cars. And one day I got an Google ad, like while browsing an article, this ad was in the left corner. And I was like, whoa, this is nice. I didn't think about, directly hacking into a connected car. To be frank, I didn't think about that. I was like, research more about the telematics control unit then to start. But this ad what changed the whole perspective. After reading this, I understood that there's a connected car in India as well. So the next thing was like, I learned about the car, what this car does, and what are the functions of or what are the advanced features of this car. Then Honda, like I came across the Honda Connect app. A Honda Connect app is was developed by Honda, and this app can be used to control the car. It has various features, and like it can be used to even a smartwatch can be used to control your car. That was Honda's whole idea. So the only two cars that supports the Honda Connect app is the Honda City 5th Gen and Honda City EHEV. That's the latest electric model of City. So like Honda app also supports with the previous versions, but it doesn't have the connected features. It just has the owner details and like and stuffs. So though this vulnerability only affects in these two models, that's City and City EHV electric variant. Okay, so let's talk about the features of Honda Connect. Honda Connect has a tire deflation alert, roadside assistance, service scheduler, payment gateway, tow away alert, and find my car, remote operations, car dashboard, etc. So it can I guess there were 30 plus connected features here. So the features what that I was interested in was these four: car finder, boot open, and door unlock and lock, and AC on off. So these are the four things that I was interested. So car finder is something, you could find your car. Where is your car? You could triangulate your car. And the boot open, like by the name itself, you might understand. So these are the four things that I would like to test. Then this is how the whole thing works. The mobile application connects with the Honda server. The Honda server interacts with the telematics control unit, and this is how the whole thing works. So I know the enumeration or the reconnaissance phase was like, Google search was my first thing. Then second thing was I contacted a Honda dealership, and I just talk with the executive about the features, about how they configure. So they, it's all about it's the application is fully configured by them, and they gave the application, just give the URL to download the application to the owner. So that's how it works. Then I downloaded the application from Google Play, and I just reversed it in the static analysis. Static analysis somewhere like it's a phase where it's a phase of testing where we just analyze the code or read the code. So in this phase, we don't need to actually run the application. Instead of running, we just but decompile the application and read the code. Before that, I would like to give a basic idea of Android applications. Android applications are written in Java or Kotlin, and it's like a zip package, a compressed package, and you could decompile it. When you decompile it, there are multiple files, multiple there'll be Java files, there will be XML files for the alignments or the design, etc. So this is how an Android app looks like, and you could decompile it to read the Java code. And while I decompiled it, and I could see some code where an API was placed. You could see the prod API.honda connect.in. So I understood that this is the API which interacts with the telematics control unit. So I was like, wow, this is cool. So this API is very important. Then after that, the dynamic side. Dynamic side is the side where we run the application. So here we install this application in a actual mobile device and test for vulnerabilities. So before, there were two things that was placed by the developers or the Honda developers. Those were root detection and SSL pinning. These were the security controls to protect the application. Root detection is a security control where which doesn't allow this application to run on a router device. You could see the notification here. So Honda Connect is not compatible with router device. The reason why the developers do this is because security analysts or pen testers use router device to test the application. So we have much control over this application than a normal device when we install it in a router device. That's why we use a routed device for testing. So this was the first thing. Second one was SSL pinning. SSL pinning is like it's a second, it's another layer over the SSL security, and it's like there will be a client side certificate and a server side certificate, and the both when the both certificate matches, the traffic is traffic will be smoothly flown. But if there is a change in this certificate, the whole traffic will be blocked. So for example, this is mainly for blocking man-in-the-middle attacks mostly. So this was the second security control. So by my day-to-day security testing or my security life, I have seen many applications with that. So we know multiple bypasses or how to bypass these security controls. So there are some tools for this. First one is Genymotion. Genymotion is actually not a tool for pen testing. It is an emulator. Since it's a mobile application, you need a mobile for testing. But there are some restrictions with the some mobile applications. Like some mobile applications only run on some specific devices or OS versions. This makes people like me, it's like I need to own every devices for testing. But Genymotion can save you from that. Genymotion can be used to emulate a particular Android OS and for a brand, like you could run Nexus, Samsung, etc. So Genymotion is a good software to emulate or you do pen testing, Android pen testing, mobile pen testing. Yeah. Then comes Frida. Frida is it's a dynamic JavaScript injector for a tool. For example, if you want to change some particular code or a particular client-side code of an Android application, you could use Frida to dynamically inject the code and run. You could see the result there. So that's how Frida works. Then comes the Burp Suite or HTTP toolkit. These are the proxy tools to analyze the traffic. So when I install this application, this is how it looks like. The application asks for a number, the mobile number, the owner's mobile number. So this is the front page of Honda Connect app. When you install it, you could see the phone number. This is the only entry field there. So as I mentioned, there's a root detection protection. So root protection. So I use Frida to bypass that security control. I was able to successfully install in a router device. So first phase was done there. Then comes the second thing. The second thing was SSL pinning. SSL pinning is SSL pinning is for blocking man-in-the-middle attacks. So I bypassed that and I use the tool HTTP toolkit to analyze the traffic. Closely looking, you could see that this is the API, Prod API Honda, and they were this is the when you give your number, this is how the app works. You give the number, the app sends an OTP to the number, and when you enter the OTP, you could get the access. But while analyzing the API traffic, I understood that the OTP was leaked in the response, the HTTP response. You would see that generated OTP, it's 5613. So this is the vulnerability that allowed me to hack into the car. It was, yeah, it's a simple vulnerability. The OTP is being leaked in the response. So uh, I entered the 5613 in the OTP field, and I got to the next page. The next page was it's a different thing. It's enter MPIN. MPIN is like, um, when you install this application, you will get where you give your phone number and the OTP will be sent. And when you give your OTP, you need to set an MPIN. MPIN is a 4-digit pin, and if you're not interested in setting up the 4-digit pin, you can also use your default phone lock. That means your biometrics or the pattern lock that you use as you wish. But since I use an emulator, this application doesn't ask for the biometrics lock. It asks for the MPIN, 4-digit MPIN. So I know, obviously I don't know the MPIN. Only the owner knows the MPIN. So I use the forgot MPIN, and with the same method that I showed I was able to steal the OTP, the 2586. I entered it and I reset the MPIN to 1234. So after that, I was successfully logged in. I got the car. The car was logged and everything. This car was approximately what about 60 kilometers away from me. So this vulnerability was so simple, but the thing is, it was very impactful. I was able to take over the car anywhere from the world. So this is the impact of a simple vulnerability. And the next thing was like I was able to unlock the car, start the engine, and unlock the boot, etc. I could do everything that the app offers by the APIs. So this is how I exploited the vulnerability, and I when I found this vulnerability, I reported it to the Auto ISAC first, then to the Honda India team. I got the response from Honda India team within 10 minutes, and they scheduled a call with me, and I demonstrated how I found this vulnerability, and they were within matter of time, it took around 3 or 4 hours to fix the vulnerability. They gave me they asked me to check or recheck the vulnerability. I checked the vulnerability, and the vulnerability was properly fixed. And those the Honda India team was so supportive and so helpful for other processes. So I would also like to thank Honda India team for fixing the vulnerability in a short span of time. This is the first time I am seeing that and in my bug bounty and my pen testing career, this is the first time I'm seeing a company fixing a vulnerability so fast. It was very fast. They called me, I sent them the report, and they fixed the vulnerability. It was very fast. It all took around 4 hours, I guess. So now the Honda City 5th is completely safe, and it's the vulnerability no more exists. And this is how I found the vulnerability and how I hacked a car. So thank you so much, everyone, for listening to my talk. And if you have any doubts or clarifications, you could reach out to me in my Twitter. I also have you could also find me on LinkedIn by my name, Mohammed Shine, and you could ask me the doubts, or you could contact me in any of the social medias. So once again, I thank ASRG and the Secure Streets team for inviting me. Thank you so much. Thank you everyone for listening to my session. Have a nice day. Bye.
Amazing talk from Muhammad. Unfortunately, he's not available for questions today, but we got a new, really interesting talk coming up next. Stay tuned.